Hello, everyone. Welcome to DBAMA. This week we are hosting Michael Coburn, who works at Percona, and he is going to be talking about Percona monitoring and management. Again, as usual, don't hesitate to ask your questions as they come up. Feel free to post them in the chat channel as well. If you don't want to speak up, then we can ask those questions for you. Most of all, we just want to have an engaging conversation about this and make sure that everyone's questions are answered. Having said that, Michael, I pass the mic to you.
Thank you, Liz the Blizz. Michael Coburn. I'm a consultant here at Percona. I've been with Percona for about 8 years. And over the last 3 years, I was responsible for this product called PMM, Percona Monitoring and Management. And what it's intended to be is a visualization tool for the behavior of your open source databases. So our technology covers the 3 main technologies that Percona is invested in, which begins with MySQL. It also covers PostgreSQL and MongoDB. The tool PMM is built on other open source products, much like a lot of Percona software itself is. We leverage Grafana, which is a visualization tool, which I'm sure a lot of you have heard of and maybe used before. And then we store data in a couple different databases on the back end. The primary one that helps us draw these pretty graphs is called Prometheus, and it's a very popular open source project for time series database storage. And then the other one that we use for a bit of a niche product called Query Analytics, that's stored in an open source columnar store database called ClickHouse. And I'll show you how what the front end or the visualization looks like and how quick some of these queries actually are, even given that they're accessing, maybe long ranges of dates or many individual data points, and it's still quite responsive. So PMM, first, please interrupt me anytime. Raise your hand or just call out and I'll stop my spiel. The product has been in development for about 3 or 4 years. We've been through 2 major iterations. We're now into PMM version 2. And the latest release was just a few days ago. We're on 2.9 now. So for those of you following from home, we had our GA release back in September of 2019. So we're almost a year into our PMM 2 cycle as well. And what's interesting about this is that beyond monitoring those databases and getting data over time, we're not only collecting database-specific activities such as query performance or metrics inside the database, but we also can give you operating system level metrics. And I'll show you where the value of a lot of this comes in. But first, let's start with what happens when you launch your PMM instance. PMM is predicated on a client server-based architecture, which means you're going to install a PMM server somewhere in your environment, and that can be installed in 3 different methods. The primary installation method is using Docker, which means it's suitable for a Kubernetes environment or standalone Docker. You can also use what's known as an OVA/OVF, which is the open virtualization format. And that's appropriate if you're using maybe VirtualBox for testing or VMware or Red Hat virtualization. A few of the others all consume the OVA format. So that's really cool if you want to just get a really big package and pop that into your VM infrastructure. And the third method is if you're hosted with Amazon and AWS, we have an AMI marketplace presence. So you can go and search for PMM, and you'll be able to clone, deploy it on an instance, and then you have PMM running for you. So once you've got the server running, you also need to get some clients installed. We have a package called PMM2 client, and that then provides you with a command line interface to set up your instances. I just saw a question come in, so I'm going to quickly take a look at that.
Yeah, go for it.
Giuseppe. So does PMM use semantic versioning or traditional marketing-driven versions? We actually are using semantic versioning right now. So 2.9.0 means we're in our 2nd major release. We're in our minor release of .9. And in the minor releases, we're releasing new functionality. And the only time you'll see the 3rd digit increment will be when we have a bug fix. And you can expect, there should be no new functionality arrive in the 3rd decimal place. Okay, so I was saying about the client side. So you install, we have binary packages that are available for your Debian and Ubuntu's, and for your CentOS and Red Hats, you can get RPMs. And we've also got Source, like all of Percona software. This is all open source. You can build it yourself if you want, but we're making it easy to deploy by using our packages. So I won't get into the command line of it. Suffice it to say, there's just a couple commands you have to run. The first one is to say, hey, I'm a client. Where is my PMM server? You run this config command. And then the second, or maybe second or third or fourth, depending on which services are running, you need to then tell PMM what services do you have deployed locally. So you'll say, I have a proxy SQL, or I have a Postgres, or I have a MySQL instance here. Use these credentials to log in at this host. And once you have that happening, everything else fills in for you. If you have performance schema enabled, you'll start getting queries. Or if your profiler is enabled in Mongo, you'll start getting queries from the Mongo profiler into the query analytics. But before we even get into all that beautiful, what the queries themselves are, let's take a look at some of the screens. When you launch PMM, you're going to start in the home dashboard. And what you gain here is a high-level environmental overview of the activity of your deployment. And at the top, we've got some informational. This is a live stream from our blog, from the percona.com/blog. What I find useful is over on the right, how many databases and how many instances am I actually tracking? And then we have a very handy box to tell you, because we have a fairly aggressive release cadence. We have a minor release pretty much every month. So you'll have a notification that'll check once a day to tell you if you're up to date or not. And if it says that there's a pending version, you can just click, there's an update button that will appear. Just click it, give it a couple minutes, and you've got now a new deployed to the latest version. So really easy from this dashboard to tell what version you're on, how many instances you have, etc. What else do I like about it though? As you scroll down, you get some high-level information about the performance of individual instances that have been added to your environment. So in my case here, I've got some Mongos, and it's sorted alphabetically. I think if I scroll down a bit more, we can find some MySQLs. And there's an Azure and a Postgres. So what we're trying to do is, in a sense, shoehorn 3 different technologies that use similar yet disparate nomenclature for their operations. So for example, we can't always say queries per second. That's not necessarily mapped to all of the other database technologies. But we're kind of shoehorning to say this is how many operations the database itself is running. We're also able to show you OS level metrics on this dashboard. And we're using colors to give you quick high-level hints as to the health or the status of maybe memory consumption or CPU utilization, etc. That's what this overview dashboard is intended to give you right here. As I hover over, I not only can see a little bit of more of a snippet over what the value itself means, but I can also use it to hyperlink myself quickly over to another dashboard. I don't want to do it right now though, because it takes just a little bit to load these. So I've already preloaded some of the tabs in my browser so we can go quickly through them. But I don't spend a lot of time practically on the home dashboard. It's useful, but I only maybe look at it once a day just to see if I have any red. Where do I spend my time? I like to begin at the nodes level, and we call the node the operating system level metrics you can get. And so for those of you following at home, you know that database as a service is a very popular thing. I'm talking about RDS or Aurora or Azure or Google or any of these platforms that have a hosted database where you have less work to do. You don't have to manage the backups, etc., but you give up control. You lose then, to some degree, the visibility of the operating system metrics. So what Percona's done is on the instances where you can actually get a shell, get local operating system level metrics, you can then deploy one of these exporters which collects operating system metrics. And I'll show you what that looks like really quickly here. And then I'll talk about what you can do in some of these database as a service locations to still get equivalent level metrics. Okay, so we begin on these what are called overview screens. And these overviews, I'll show you what the other ones look like. If you're running a multi-database topology or architecture in your environment, let's say you're running a few Postgres, Mongos, and MySQLs or PXEs, what have you, you will then be able to see at a glance clusters of these technologies. So let me see if I can find one that is actually, oh, that's not the right one. I think this is going to be it. There we go. Okay, so what I want to be able to show you is 2 ways to visualize the health of your environment. And again, we're on the nodes overview, and all of the instances, no, I shouldn't say all, almost all of the instances, I think only maybe 1 or 2 are database as a service. So for the ones that are not database as a service, I have local shell access, and therefore I have deployed the local consumer called node exporter to get the operating system metrics. So what I do on the left-hand side is I can show you the top instances that are consuming CPU. I can see I have one server that's basically pinned at 100% workload here. I've got my PS8 that's around 98%. And on the right-hand side, it's not capped at the top 5. I can get at a glance view over which nodes are exceeding some measure of a threshold based on colors. And by hovering, I can then get the host name of it and determine, if that's an actionable instance I need to care about, or maybe it's dev, not as important to me. But the perspective is these overview screens give us a high-level perspective of the behavior of all of our nodes that are in PMM. This nodes overview will give you things like the CPU. As we scroll down, it'll show us information about memory, disk throughput, and network. The 4 main cornerstones of what you can get out of any piece of hardware that you're either buying virtually or buying in a physical. And so we can see here, well, we've got some servers that are very low on available RAM. This is always interesting for me because I'm not always watching my demo environment as closely. So I have some work, I think, in front of me here to deal with some memory allocation, at least in Mongo. And then down at the bottom, I'll show quickly, we've got a disk. Which instances, now, particularly with databases, they're very sensitive to the latency and the throughput that the disks themselves can do, whether they're network attached storage or whether they're local SSDs or NVRAMs or what have you. And so in this case here, we're able to show a load, how many items are in the queue versus what are the latencies on some of these drives. All of these, except for the database as a service, are running in DigitalOcean, and the throughput's actually pretty good. We've got some 30 millisecond, but basically they're all fairly low. So the throughput on these are quite good. And then how much in terms of capacity, in terms of megabytes, are these drives actually consuming? Okay, so all of this is available at a glance for you. Where does it get cool though? You might look at this once in a while when you're maybe triaging or diagnosing a problem. But where I like to start my days are on my instance overview dashboards for the technology I care about. And again, my area of expertise is MySQL, so I'm going to focus this demo on MySQL-based components. But if anybody else wants to hear about Postgres or what have you, let me know, and I can maybe tail that at the end.
I think MySQL works for us.
Okay. All right.
I like the part where you said this is where it gets cool. I mean, I thought it was cool already.
I was thinking the exact same thing. I was like, this is pretty cool already. It's okay. I'm excited to see what's next.
Absolutely. So what you can do on the instance overviews is, by design, I've only got a few instances in here. I think six MySQL Ds are running somewhere in my environment. I was helping a customer though just last week, and we had I think 18 different shards, and in each shard there was 120 or so instances. So we had a MySQL environment, a PMM environment that had around 1,000 hosts, more or less. And it stood up fine. I was running it on, I think we were running it on 16 cores and 64 gigs of RAM. It was humming along, no big problem. So about 1,000 is around a sweet spot for maximum amount that you can put of instances into PMM. Well, when you have that number of instances, one, you're not really caring about them in the sense of, that's my primary server or that's my most important one. You are probably dealing with it in an abstracted sense. You might hear the terms of treating them like cattle or pets, where instances are disposable and whatnot. And when you get into the more disposable environments like that, you've got a lot more labels and tags that get assigned to instances. And where these become really important is how you can categorize and look at different types of instances at the same time. So in my case here, I've got different clusters, and they might only have 1 or 2 instances per, but this really helps me when I want to zero in on and look at the behavior of just a smaller group of a collection of MySQL instances. Okay, so right here, what I like to do with this, now again, this is where PMM, I shouldn't say fall apart, but it gets a little less glued together when we talk about how does MySQL call it versus what does Postgres call it versus Mongo. So replication set, not really a term I use regularly in MySQL. I don't know, maybe, do you use that often, Morgan or Giuseppe? Probably not too much, right? I mean, we call them primaries and replicas. Well, we have the ability to tag it, and I encourage people to use the tagging because then it helps you.
There is replica sets in 8.0, but we're kind of moving off topic to cover that.
Yeah.
Go on.
Yeah. The premise is, though, is that, again, some of these names are a bit sticky, and if people have ideas on how we can improve them, we would love to hear it. That's really the point. But they're very useful to use. So what do you get out of this? This is the screen that I like to start a day. I like to look at how my replication cluster might be doing, and I correlate that with maybe some other app information that I've learned. You know, maybe my SREs are ringing me to say that, you know, last night, Michael, at 2 p.m., this event happened. With this overview dashboard, I can then see not just what the primary, but also what the replicas are doing. Now, in this case, I've got a very simple primary and replica, nothing too fancy going on here. What it lets me do is plot individual server metrics, but show them cascading across multiple instances. Hugely, hugely beneficial when you're trying to troubleshoot a problem. Okay, now again, this is a demo environment with synthetic workloads, so it's not unexpected to see flat lines. I did try to make it a little more jittery, but again, what am I jittering between 67 and 68 connections here? Not too much. Many environments, you know, you'll follow the sun, you'll see the peaks and the troughs going together. What are we looking at here? I like looking at my day. I don't actually look at the top ones. The ones I care about, probably the most important monitoring single metric series you care about in MySQL is going to be your threads running. And that is a measure of how much concurrency is occurring within the MySQL, the InnoDB kernel for satisfying queries. And as that number gets higher, you will probably see more locking events or conditions where throughput as a whole query performance is degrading. So I love the active client threads dashboard, particularly when I want to look at my replica pool. It's very important for me to see any outliers in that cluster of servers, because arguably, usually your replicas are all serving the same volume of queries and the same types of queries. So they should all be similar. So this overview dashboard really helps you highlight the outliers. Okay, and as you can see here, my workload on my primary, my PS8 MySQL, is a lot busier than the replica. This dashboard also gets into some InnoDB level details. And again, we're keeping these really high level. How many reads or writes or fsyncs are going on? We're not trying to get in to say if these are, you know, InnoDB redo logs versus undo logs, et cetera, et cetera. We have that sort of detail on other dashboards. This is just a high level, where are my pain points today? We reiterate some details, such as network details we talked about on node overview, but this comes from the MySQL perspective. How much data is being pushed through the MySQL port that's measured by the MySQL daemon. And for those of you who are still maybe using the query cache, we still got some love for you here. We don't have it enabled. I think in MySQL 8, it might have been completely removed. Excuse my ignorance. I don't remember if it actually was completely.
Yeah, it was.
Thank you, Morgan. The reason we continue to include it, though, is that this tool, PMM, will support any non-end-of-life versions of any of the database technologies I've spoken about. So I think I know it'll go back at least to 5.6, and it'll technically support 5.5 and 5.1, but you'll just notice that many more dashboards or graphs are blank as you run older technologies. And if any of you are looking for upgrade help, Percona is very, very happy to help you with planning that out and also delivering on a successful upgrade. Okay, so we have an instances overview. Now, for those of you who are a little more technical, let's say, or maybe advanced in the database space, I'm going to show a middle screen, and then I'm going to go to the really hardcore stuff. So table details is kind of an aside piece of information that I love to call it in these demos, because as a consultant, a lot of my work involves coming in cold to an environment and having maybe a cheat sheet and usually nothing, and just saying, Michael, hair's on fire, what are we going to do? We have problems here. And some of the quick things I need to know are, what are your biggest tables? Or do you have indexes in the right place, etc. Well, this dashboard can help me understand what are my largest tables measured by the number of rows in it and also the space on disk. And that informs me when I look at the schema and I look at their queries and go, wow, you know, we could benefit from an index, or we could remove an index. Well, all of those come with some sort of penalty or time to execute, and the size of the table informs on how long that's going to take to actually occur. That's where this dashboard comes in super handy. So that helps me as a technical person, and it also is very beneficial to the users themselves, who often, many database administrators don't know which their largest tables are. They had no idea, or they had maybe mistaken impressions over what the largest tables are. And again, those they impact whether you're doing schema changes. It involves how quick data can be retrieved or written to these tables, etc. So this is a very important dashboard for you to be using, I suppose. So it's plotting the database size over time. And if you're using, let me switch this to less instances so it's not so overwhelming. I'll just put it on one machine right now. Okay, so we're looking at one instance at a time. Now, the top part here is stuff you can get across all versions of MySQL. I think probably back as far as 5.1. These are being read from information schema. There are some features though that Percona server has added that are outside of what upstream community does and what MariaDB does these days. Now Maria followed ExtraDB for a while, and then memory doesn't serve me as to what version they split off again. But there is this feature in Percona server called UserStat. And what it gives you is a great perspective on the activity on a per level basis. And why this really matters is I've talked earlier about I have to make a schema change on my data set. Well, I care about how big that table is because that's going to tell me how long approximately it's going to take. But you also might care about when that table is busy. And generally busy means when it's being written to or being updated. And so the user stat variable, when it's enabled in Percona server, can give you this over time, where are my peaks and troughs? And it might be that you always thought at midnight was the best time to run schema changes, but you look at the graphs and say, we don't do any updates between 10 a.m. and 2 p.m. That's when we should run the schema changes. That's what this dashboard really gives you some insight into. This section, as we get into the rows read and rows changed. Particularly rows changed is what I'm getting at with what is the right activity on it. So very cool feature. And one last thing I want to call out, and I'm just going to highlight in case Shalomi's watching this. Well, I guess it's not Shalomi anymore. I think it was GitHub had a little problem last week around some auto increment exhaustion. And I'm not calling you guys out in any bad way. It happens. And I think it was on a related table related to foreign keys, et cetera, et cetera. But the point is it's important for you to watch how filled your auto increment integer types are. How close are they to being exhausted? And that's what this is giving you in an always running version. Yes, you can write one-off scripts, but it's always more practical if you can have this in a repeatable way. You load the dashboard and see how close are we to exhausting the capacity of that integer type. Okay, and that's what this bottom section is right here. So I love this dashboard. Very, very practical. Okay, I don't see any questions. I'm going to go to the hardcore, and then I'm going to come. Oh, go ahead, Morgan.
I have some questions, but I'll ask them now. But if you want to answer them in the end, that's fine. So you showed sort of like resource saturation, and then I think you showed some query time. I'm kind of curious to hear at the same time your wish list of requests for better metrics from database vendors, particularly previously being in that position. Like, I'll give you two examples of my requests. I would love to see resources consumed by user be more of a focus, and time per transaction rather than just per query. And all associated things per transaction, queries per transaction, wall time, sys time, etc.
That's a really good point. And other database types, I think Postgres has some very good consumption metrics on a per query. I'm not sure at the transaction level, but at the per query, they can tell you how much CPU and disk was consumed.
Yeah, I want per transaction. I don't know how many vendors do that, but yeah, you can answer at the end as well if that works better. I'm just kind of curious your wish list, because I think that's a really interesting perspective as a developer.
Yep. I'll come back to that because I think I want to think that through, but those are some fair points. Okay, so let me show you the hyper technical stuff. What we used to have in PMM was two different dashboards that talked about InterDB, and we called them InterDB details and InterDB advanced details. One was more advanced than the other. We've consolidated these. Peter Zaitsev, our CEO, spent a lot of time, I think over last Christmas break, or I don't know, I think it was last year sometime, and he really merged things together and updated them. So I'm going to open these a little bit one at a time because they take a little bit to load. But what do you get out of this? You get everything you could ever imagine of every InterDB metric plotted in some way, shape, or form. And we've used two main ways to detail that information to you. And I'm going to use the words that, or the phrases that Grafana uses to call these objects. This here are called single stats. They are generally reflective of a point in time. What is the definition of a global variable, perhaps? Or they're showing an average over a very short fixed period of time, maybe 5 minutes or something, right? So max transactions over the last hour or the last 5 minutes, something like that. They're very quick snippets over, as a database consultant coming in, I want to know how many InterDB persistent sample pages are being used. Is it 8? Is it 800? Has the customer misconfigured, or that sort of thing? That's what jumps out at me very quickly. And we've leveraged colors to highlight, in our opinion, what are some troublesome cases. They're not always going to be accurate. And again, we welcome your PRs. This is an open source project. If you have changes, we would love to see those, and we will consume them and give you recognition for those fixes. But we use the single stats to call out point in time. And then we use what are probably more common to everybody, are graphs. You're plotting one value or maybe multiple values over time. So what do you care about in InterDB? Well, InterDB uses what's called a buffer pool to stage data that's come from disk, goes into a memory space, and InterDB, MySQL, acts on data in memory. And then everything else around that is, how do we persist that safely to disk so we don't lose events if we crash, or if we're promoting machines around between primary and replica states, that everything stays in sync. Years and years of engineering effort has gone into that protection and those guarantees. But as database users, when things are running normally, we care about things like, what is the throughput of the reads versus the writes to the other resources we talked about on the nodes dashboard. So we highlight those first. The InterDB activity is often going to be bottlenecked by those other resources. So what I look for when I look at these generally are flat lines. Do I see something that looks to be saturated? Okay. A common case these days, data sets are growing larger and larger every day. And so you'll find that your working set, whatever is important to your application, ends up being larger than what's available in memory. So you become what's known as a read-bound workload. Data has to be continually fetched from disk and pulled into memory. And so this graph right here, row reads, will show, I'm sorry, I think this is from memory. There it is, storage. I'm getting ahead of myself, I'm sorry. We've got different graphs that show the disk throughput versus the in-memory. What I'm talking about is, what is the I/O throughput? In this case, you can see it's a flat line, but actually it's 0 for data reads. So I don't have a disk-bound workload, but if I did, I would see my green line up a little bit higher, and if it's actually disk-bound, it would be high and flat. And that would tell me that either I would benefit from faster disks potentially, or a larger buffer pool, meaning I need to buy a larger instance size. Okay. Coming back to the top, these row reads and row writes, this is what's actually acting on the in-memory space. How many updates or inserts are actually occurring, and how many events are changing data within InterDB. I won't go through all of them because we've got about 14 or 16 different collapsed windows, but we're plotting the most important data. So how many transactions are ongoing, ones that are changing data, which are our read writes versus our read-only transactions, etc.
Right. I like row reads as another one, kind of like threads running that you were talking about. It's a general like demand on the server stat that's kind of interesting. It's just like the base operation that everything is comprised of.
That's right. And at some point, there is going to be a saturation level for virtually every metric, including the amount of rows you can read from a memory space given a fixed period of time, whether it's a second or 5 minutes. Okay, so our other sections, we've got what's happening within the database itself from on disk. How quickly are we fetching data? How much data are we fetching from disk? How much is being consumed by fsync? So we're synchronizing data that has been committed to a log. How often are we asking the operating system or the block device? How much are we asking it to quiesce and acknowledge that it is synchronized and persisted that to disk? These are all important metrics that you might leave enabled for highest level of guarantees. So if a server fails, you don't lose any events. But in cases where you're running into performance bottlenecks, you disable that. And these graphs will inform you what's your risk level if that server crashes. You can estimate how many transactions I might lose, for example, if my server failed right now, how many were in flight. And every application is going to have a different consistency guarantee. I was helping a customer last week on 2 different deployments, and on one of them, they didn't care. They would reproduce events over the last 5 minutes if the server failed. So we ran with the doors wide open. And on the other side, it was a very locked down. It was based on money coming in the door. So every transaction mattered. So throughput was dramatically reduced because we had to limit these values. And so that's where this dashboard can show you how much am I artificially or intentionally lowering or limiting my throughput because I have consistency guarantees I want to assure. Okay. What was the other one I wanted to show? I think it was just the buffer pool. This can inform you. It doesn't show, so it's expensive sometimes in MySQL to try to say which tables are memory resident. Reading from some of the info schema tables around buffer pool and then categorizing based on space IDs, et cetera, is very time consuming, and they can sometimes lead to blocking conditions. So I get that question a lot, like, well, Michael, can you tell me which tables are resident? Technically, yes, I can, but I don't want my tool doing it because it has to run that query regularly enough that it would impact your performance. But I can tell you how populated it is, how much space might be free in your buffer pool, and really what's important here is how much of it is actually dirty. And dirty data in your buffer pool means data that's been changed, that has been persisted to a log, but has not yet been persisted to the IBD files, to the durable MySQL InterDB files. And that's what we're informed about on the buffer pool dashboard primarily, section of the dashboard. Okay, I'm just doing a quick time check. I'm going to move to another dashboard, and if we have more, I can come back to this hardcore one, but I don't want to lose too many people in some of the low-level details.
I don't think you've lost anyone, but feel free to proceed as you prefer.
Okay, because I want to save some of the excitement, because when we get to query analytics, heck, let's jump there right now. This, I think, is the niche feature of PMM. I think it stands apart from other I guess software as a service, or even other on-premise deployments over what are my MySQL metrics right now, okay? It's relatively straightforward to bootstrap your own Prometheus with Grafana. You can use Percona's dashboards. They're also open source, pop them in, they're just JSON, modify a couple strings, and it works for your environment. So it's fairly easy to reproduce that in your own environment. You're probably already doing it today at some level. Where PMM makes it easier is that it's already bundled. You don't have to know Prometheus. You don't have to know Grafana. It's just a package, and it just works. So PMM's easier, but it's easily reproduced on the metric side. Where it's a little trickier, and what I love about this is not only is it very unique, but it's also very, very powerful. We call it query analytics. And if you've been using MySQL for a while, you're probably familiar with Percona Toolkit. And if you're familiar with Toolkit, you're probably familiar with one called PT Query Digest. It is a tool that can consume a variety of different sources, but you usually use the slow log. You pass the slow log to this binary, and it outputs this digest, this text-based output that says, where is my server spending its time? And it builds that metric up based on slow queries. Well, a slow query for most people is defined as just really long running, 10 seconds, 15 seconds. Oh, that's slow, Michael, fix that. Okay, yeah, that's slow. So the server spent 15 seconds executing that query. But the other side, which often gets missed, is the query that runs in maybe 100 milliseconds by itself, wicked fast, everybody's happy with it. But if that thing runs 1,000 times or 10,000 times a second, that's a non-negligible workload for the server to have to satisfy, and therefore takes away resources from other queries from running. Both of these models, the slow query, the 15-second versus the 100 millisecond, have different improvement options. You know, in the slow query, you might have index improvements or hints to the SQL for which indexes to use, etc. Whereas the frequently running query might be cached or some other tuning option. But the point is, both of these consume resources. And I say all this because that's what Query Digest is going to show you. It boils this all up. Well, great. I like text. Maybe you like text too. But the drawback is that it's a one-off. It's an ad hoc running. Now, there's some facilities to build these query history tables, and you could use cron tab to build your own always running Query Digest, but it's probably error prone, and I encourage you to use a tool like Query Analytics. So enough about the history. What do you got in front of you? You've got, by default, a view of all of the technologies, which is really cool. You're going to get MySQL, Postgres, and MongoDB all in one view. So if you're a multi-architecture shop, you can tell where your database is spending time right away. It will give you all the metrics you're getting from the slow log. So depending on which version of MySQL you've deployed and which flavor, I suppose, Percona server with the extended slow log has additional information in it. Things like how many pages were read from disk from InterDB, which isn't exposed by the community version of the slow log, for example. All of these different pieces that you get out of the text file are also part of Query Analytics. And with that, you can sort by it. Okay, so by default, this is kind of like a GUI version of PT Query Digest. It's sorting by the load, the amount of time that MySQL, in this case, had to spend answering a query. So our first most painful query is running about oh geez, sorry, let me log in real quick. In our demo environment, it doesn't always show the, so we had to modify our demo environment to work properly sorry, bear with me. I need to now do LastPass because I chose to use an incognito window.
It's okay.
If I could dance, I would do that right now too, but
no, don't worry. The whole point is kind of, do demos and watch demos fail. So
yeah,
that wouldn't classify this as a failure even. I mean, it just happens.
I just hope I'm picking the right username and password here too. So please.
I guess because it's internet accessible, you don't really have a choice, right?
Yeah.
You can't just use admin.
That's right. For those of you following at home, admin is our how do you get in without any other settings being modified. Okay, I think I know what I've done wrong here. Let me grab my other password, paste that in, and hopefully we get in.
No.
Percona's LDAP. What I highlight here is that you can integrate this with any of the open source, or not, I shouldn't say open source, with any of the LDAP infrastructures that might be deployed. Open LDAP, Active Directory, Okta, any of these things are all supported as a backend authentication system for PMM because that's what Grafana supports. So very cool to implement it into your enterprise. Now that I'm logged in, you can see a little bit more data has shown up. And in your case, again, I want to be clear, you don't need to be logged in normally for this stuff to show up. Again, this is just because it's a demo environment. It's publicly available. We had to make some by hook or by crook to make it work. But okay, so what am I doing here? Now I've highlighted the busiest query. And the busiest query is the one that is, make sure I'm showing all of the columns here. It's sorted by this load factor here. And it's basically building up this value based on how often it's run and how much resources it's taken from the server based on time. Okay. So this is the most painful query. If I'm going to optimize a query as a consultant, I've got limited time to work with you. Which one should I focus on? And it's the same story that I think applies for any DBA. You might have 1,000 or 1,000,000 distinct queries in your environment. Only a few of them might actually be material in the sense of spending time to fix. Others just run fast enough or infrequently enough that you don't care about them. So this tool helps you focus your attention. Where should I be spending my time to fix? So we select this update. Oh no, let's pick a select. Selects are easier to understand.
Is load factor just query count times query time, or does it have some math to figure in that this one's very spiky, so it escalates a little bit higher?
There is an algorithm behind it. Top of my head, I'm not. I have been asked it before, and I do feel like I should be able to explain it better. I don't know off the top of my head though how it's computed. Okay,
so it's roughly probably count times query time, and maybe it counts for spikies as well.
I think so. I think so. Yeah.
No problem.
That's right. So when I drill into this query, I get these 4 different tabs down here at the bottom. So I'll start on the details one. This is the data that you would get out of your slow log. If you just opened it up, found this query, you would see a single instance. How long did that query run for? How long did it lock, etc. But the cool thing about this is it's showing me those values plotted over time. Okay, and it's then giving me some summation around it. How often has this query run? Now I'm looking at a 12-hour period. I've run it almost 9 million times over the last 12 hours, which roughly breaks out to 200 queries per second. You'll get these numbers from PT Query Digest, but you won't get this nice distribution of the events over time, which is really helpful when you're trying to explain maybe to your app developers or other DBAs even, look, at 12 o'clock, we get this big crash of queries or etc. Which query is causing the problem? Very quickly up here at the top, you can see which ones exhibit different performance characteristics at different times. So these little mini graphs are super, super helpful. Now, in this particular query case, it seems to be returning an identical amount of rows every single time within 1 or 2 rows. Okay. And what else I like to call out about this particular view is I care very much about the ratio between rows examined and rows sent. That is effectively a measure of how efficient your indexing strategy is. And the best you can get is a 1-to-1. Every row I examined, I sent back to the client because it matched the where clause, the index condition. Okay. So in this case, hey, whoever developed this has a very well indexed system. Oh, when I look up at it, I can start to glean that there's only an ID equals possibly only one value. It's not an in. Might be it's a primary key, so that's a very selective index to use. I happen to know that because I know this is sysbench and I know what the schema is, But if you want to be able to look at it, please don't fail me. Yes, this used to be a bit of a bug. So create table in our demo environment, it always worked on the on-premise. You can get the create table out of this tool. And this is, I guess, kind of the second facet I like to call about query analytics, is why it's really important. More and more of my own engagements, I'm not even being granted permission to their environments. I'm not even getting VPN accounts. So I'm not able to shell into those database servers. I'm not able to get a console. I'm not able to run my own show create table. But if I've got that customer to deploy PMM, I don't need any of that. I can do an audit. I can do a lot of my review remotely, because I can then crack open this create table, index, oh, there we go, and status information about these tables. That's helpful to me. That's very selfish of Michael to say that, but it's very helpful as a consultant. But it's also helpful when you're looking to have a conversation with other members of your team. You might be on a large database team, and there's a lot of databases out there deployed, and not everybody has the create table in their mind. It's much quicker to show them this on a screen. They don't need to do two-factor to authenticate to the database backends. A lot of customers have that, etc. So it's all in front of you. And the other part of this I'd like to highlight is to the developers who are working with the database administrators. This tool of PMM can save those engineers who usually don't have access to prod environments, who have other ways to find create tables, but it might not be consistent with the prod version. Having this all in one piece of one pane of glass is really, really helpful for having a shared language between your developers, your database administrators, and maybe your DevOps or SREs. Okay, so what do you get out of it? Create table is really important. I'll come back to about the filtering and the where clause information. We spoke about the rows examined versus rows sent, but you'll also get the status information. So show table status for SB test 1. Okay, what I really care about here is how many rows are in this table. InterDB is based everything on statistics. I know this is a nice round number. I think my number is, if I get my decimals right, it's 100 million rows in this table. So it's kind of a little bit off, but I know it's precisely 100 million rows. I care about that. And out of indexes, what I care about is this cardinality value here. How selective is this index? And in this case, it's a primary key. Well, in InterDB, primary keys have to be unique, and therefore the cardinality value will be the number of rows that are unique. And again, it's going to be the number of rows in the table. And again, because it's statistics, these numbers are close, but they're not exactly the same. So this also helps when you're talking to the developers. Hey, look, developer, it's not my perspective. Here's the number showing how many rows are in the table, or where the indexes are, or where we need to put indexes. Okay, so let's go back to the details when I talked about the one-to-one relationship. We've got the rows examined equal to rows sent. I can show you an example of what the query looks like. So I'm filtering on a single value here on the ID field. Well, I forget what the ID field is. In my show create table, I can see the ID is an integer type, obviously, and it's also the primary key. So I can make an assessment that this is there's not going to be an indexing option really to improve the performance of the lookup of this query. Now I look at the example and I see it's actually selecting C, column C. Go back to my table. Maybe you could mess around with a compound index of ID, comma C. Maybe that would net you some benefit, maybe not. There's always some level of art versus science to indexing strategies. But the point is I can tell very quickly through these different screens how effective my indexing already is set up, or where I have a lot of room to improve. Okay. And last but not least, you get the explain. Probably the most opaque, but probably the most useful component of query tuning. And I like it printed with the \G. So I always struggle even looking with this thing as a row. But anyway, what we're looking at here is we care about which keys are being selected and how many rows. These are probably the two most important fields you care about. In this case, because we know it's a primary key lookup that we just figured out ourselves, this informs us that yes, in fact, the optimizer could select the primary key. It did select the primary key, and it did return one row based on our where clause. So that's the whirlwind tour through the details, examples explained in table section of query analytics. Okay. I just want to show real quick, and then I can open it up because I'm at the tail end of it. You can sort by a whole bunch of different components of your database characteristics. So here's a good one. You might say file sorts. Well, queries are, no, maybe let me find a different one. I want to find one, I think, around disk. Let me see.
Like temperature tables or something? 10-minute warning, by the way.
Yes, okay, thank you. I like this one here. Okay, a classic case of what we get from a customer is my database is performing slowly. Okay, well, usually you're limited by some sort of resources. And this isn't coming up as well as I thought, but I think this will work. Well, okay, we'll look at some graphs, and our OS graphs will inform us that maybe we're saturated on our disk. Well, maybe budget doesn't allow for growing by credit card by just scaling the instance size or buying more IOPS. Okay, that's the situation we're in. What do you do about it? Well, what I would do then is I would immediately come to Query Analytics and do a sort by the InterDB IO activity. Which ones are doing the most amount of disk-based work? So I would highlight that as a column and I would sort by it, and then look at those queries first as those that might be valuable to optimize. They could be cached. The result sets may be too wide. Your ranges are too wide. There's a bunch of different ways that you can control the volume of data that's being read. But you're able to use Query Analytics to target very specific problem, resource-based constraints you have in your environment by slicing and dicing and by doing the different types of sorting. So that's a very useful case that I was just using earlier this morning. I had an engagement with a customer where they're hitting their max IOPS, and we've been sorting by disk-based workloads. So I think I'm at the end of what I wanted to get through with everybody. I covered off how we look at metrics over time, and I talked about where Query Analytics fits into the whole package. I'll just highlight that with MySQL, you have the option of using performance schema, the query digest tables, or you've got the availability of the slow log. The slow log is generally a bit richer. You get things, now I think performance schema will give you the query time and the count, but it won't give you lock time, or there's a couple other facets that are missing out of performance schema. It's generally a little more performant to fetch data from performance schema versus a slow log, but the slow log is richer. So I generally advise customers, if you can, turn on the slow log, set long query time equals 0, and point PMM against that log file. And you'll have a very useful Query Analytics where over time, you'll be able to optimize your queries and then use this tool to stay on top of any new queries being introduced into the environment and optimizing them before they become a problem. So with that, I want to say thank you, and I want to hand it back over to Liz.
I actually have a question.
Okay.
So I know that PXC also gets deployed on Kubernetes, and you talked about OS level metrics. Can you show me what that looks like? Do you have a sample of that in your overview?
I don't have a Kubernetes deployed system in the demo. And now this is me, I'm not a Kubernetes expert. I'm just thinking of my last engagement last week that wrapped up was a Kubernetes deployed environment. And I was trying to build OS metrics into it. And the OS metrics for Kubernetes are consumed by different sets of exporters. So I wasn't able to easily unify everything into one view in PMM. What you can do though, oh, sorry, go ahead.
No, that's what I was curious about. Like, what would you recommend and how would you approach it?
Okay, yep. What we've got as part of the PMM suite is this functionality from the command line called external exporters. And what it really means is the Prometheus ecosystem is very rich. It's a very active project. And we're using 4 consumers, 4 exporters. But there are hundreds more, literally hundreds more. I know there's ones out there for Vitesse and many other products. And what you can do with that through external exporters is deploy the exporter, point it, this is what you do on your own. You deploy it and you point it at your service. And with this external exporter syntax of the command line, you can then have PMM start scraping, start consuming metrics from that exporter. Now, PMM has not only your MySQL stuff, but it's got your Vitesse stuff or your Kubernetes CPU stuff being plotted as a metric series. And then it's an exercise for the user, or if your Percona customer will help you with this, design dashboards to unify the two. And so what you can do then is on your OS, your nodes overview, that's what I wanted to highlight earlier. Thank you, Liz, for bringing this up. In nodes overview, not only do you have ones that are using the node exporter, meaning I have shell access, but you can also get your, here you go. We've got an RDS instance in here. And how did we do that? Well, there's an RDS exporter, or I think it's called CloudWatch or something like that. But you can sometimes hook into these APIs and you can consume whatever the cloud vendor is giving you in terms of those pieces of data. So that's one way where we built into the product for Amazon. But if you're using external exporters, you can hook into other database as a service products if they expose an API, because I'm sure there's a Prometheus exporter for it, Or if it's just another service, perhaps Cassandra or Redis, they all have exporters. You can hook those into PMM. And then the beauty is you can unite those on the same graph to say, when Redis does this, MySQL does this. So let's build a graph and an alert based on those conditions arising.
Well, you kind of read my mind. I mean, of course, I was thinking from the viewpoint of Vitesse and trying to get all these sweet visualizations onto there. So thank you. I have to take a closer look at that. I think Giuseppe mentioned having 2 questions. So.
Okay, yes,
go ahead, Giuseppe.
I do. I have a boring question. The boring question is how much hardware do I need to install this? So what are the requisites? More specifically, can I install everything in containers, or do I need dedicated servers?
I would not skimp on resources for PMM. And the reason is, well, for any monitoring platform, it will consume a significant amount of resources. You will want, most of the, if not all, of these services are written in Go. So they're multi-threaded by design. So the more cores you can give it are generally the better. I would encourage you on a high-end deployment of several hundred machines, probably 16 cores, 32 or 64 gigs of RAM is what you would need from keeping the binaries running smoothly. And then where you also will pay a penalty is on disk consumption. And actually not only disk consumption, but disk throughput. And what happens here is the workload of these databases is a little bit different than what we're used to with our OLTP or our transactional-based databases. So with what mostly I see with MySQL is a peak and a trough throughout the day, and I've got varying workloads, and I might have a lot of reads at one point and a lot of writes at another. That's not how time series databases work. They operate on a clock. They reach out and they have a fixed number of writes that they're going to do every second or 5 seconds or what have you, whatever their clock schedule is. So when you look at their throughput graphs, they're very heavy on writes, but very consistent. As you add more nodes, they'll increase and they will stabilize at a level. So you want to provide for good throughput on writes, because if the writes can't be done quick enough, then Prometheus will start timing out. And what Prometheus does on a timeout is it discards that data point. Well, with one lost data point, no big deal. But if you start getting enough of them, when you look at these graphs, you're going to have gaps in them, and therefore you're blind for those periods of time. So provisioning high quality drives and capacity is important for Prometheus. Heavy on the writes, relatively light on reads. The reads only happen when you're writing alerts or fetching dashboards. And I'll just say quickly around space consumption. It depends on your retention period and depends on how aggressively you're scraping your data. As a database guy who's swooping in for a couple days with you to solve your hair on fire problem, I want you to just burn the resources. I want you to collect things at 1 second so I can tell you very clearly how things are going. But you might say, well, you know, in regular times, 5 seconds or 10 seconds are better for me. Okay, well, that means you're collecting less data over time, therefore your disk requirements shrink. And now I'm talking about capacity. That's version 1 of it. Version 2 of capacity is how long do you want to sit on this data for? By default, PMM is 30 days. Some customers say to me, well, I'd like to compare 2 Black Fridays against each other. Now we're talking a year plus. There's no theoretical limit to how long you can store it. Prometheus will let you do it, but it will cost you a significant amount, probably in the terabytes of disk space. So there's a trade-off here. You can sit on this 1 second resolution for a year if you want, but now you could be talking 5 or 10 terabytes. So there's a trade-off as to what you actually value versus what you want to spend money on.
Okay, thank you. The other question was, you mentioned contributions are welcomed. I had a look at the GitHub page of PMM, and I see that there is a list of 16 repositories. So what do I need to know to contribute to PMM? You mentioned that there is Go, and you mentioned that some of Percona toolkit are used. So we have Go and Perl. What else?
I'm not on the engineering team, so if any engineers are watching, I hope I don't butcher this. But by and large, the newer code is based on Go that we're developing. And where we see the bulk of our contributions, I think where it's not only easiest, but most impactful, both to your environment and to the community, are in 2 places. One is in the dashboard. The dashboard is text. It's stored on disk in JSON format. You don't even need to know the JSON. You edit everything by editing the dashboard. Oh, I'm not logged in as an admin, but I could normally edit this dashboard and make changes on the fly, hit save, and persist it to GitHub through a git commit. So adding new dashboards or editing dashboards, maybe we got the formula wrong. That is our number one, I think, most useful way that you can have an impact with PMM, custom dashboards. Part two is on the exporters. The exporters, we're trying really hard to keep up with the current releases, but they lag. I can tell you right now that the proxy SQL has really good support for version 1.4, but it's missing some sources for the 2.0 releases. Okay, well that means then we're waiting for somebody, whether it's Percona or somebody in the community, to implement, you know, the hooks in the exporter, so that then now the data is being consumed as a time series, and then either yourself or Percona can then write the dashboard to consume those new metric series. So I always start with telling people, start with the dashboards. They're really easy to interpret. They're easy to say, well, I have this unique thing about my environment I want to look at. Create a custom dashboard. As you get comfortable with that, then look at the exporters and maybe what data source is missing from there that you might want to add in.
All right.
Makes sense. I just want to say as well, Michael, you did answer my question from earlier, what you want from database vendors, by saying performance scheme is missing metrics. So good to know.
Mm-hmm. So on that note, I think it's time for us to end our recording. If there's any more questions, of course, Michael, if you have a couple more minutes, we can wrap those up after. But thank you very much, Michael, for joining, and everyone who's watching this as well. It was really, really nice to see how far PMM has come over the past couple of years. So I was very impressed. Thank you.
Well, thank you. Thank you for the invitation, and it was a pleasure.